All right, Algebra 3, Lesson 32. What we're covering here today is inverse functions, four-quadrant sines, and inverse trigonomic functions. There's a lot of different stuff in here. The first two, what we're talking about there is just the inverse function. So that you're aware of this, there are really only two rules. If you do these two things, you should be able to find the inverse function every single time. Okay? Rule number one, switch x and y. Okay? That does not include their coefficients. Okay? So anything that's, necessarily attached to the x or y doesn't move with it. So if you look at question number 1, it doesn't become 5x equals y minus 3. All right? It becomes x equals 5y minus 3. Do you follow me? Okay, so just the x and y move to their corresponding places. Rule number 2, solve for y. That's it. The only two things I have to do to find the inverse, switch the x and y, solve for the y. Okay? So with that in mind, all right, I'll do the first one. You guys do the second one. I would get x equals 5y minus 3. Okay, if I want to solve for y, I'm going to add 3 to both sides. All right, so I got x plus 3 equals 5y. I'm going to divide by 5. Right? A lot of times they'll let you leave it as x plus 3 over 5. An equivalent form of that would be x equals 1, or y equals 1/5 x plus 3/5. Okay? Either one of those is typically acceptable. I like the second one because it puts it into slope-intercept form for me, right, which is what I started with, but they're inverse slopes. They're not perpendicular slopes, right? You notice that? They're not perpendicular because it's not negative 1/5 x. Okay, they are inverse of each other. So don't expect to see something where I have two lines that are now at right angles from each other. Okay? Inverse doesn't mean perpendicular. Okay, do we follow that part of it? All right, so I want you guys to do question number 2. I'll leave this work up and see how you guys do with that. I'll pause it to give you guys a second. So what was for 3 minutes for us was just a second for you guys. So what answer did you get, Emmanuel?
Y equals 1/4 x minus 1/2.
Perfect. Y equals 1/4 x minus 1/2. Is there an equivalent form of that equation up there in the list? B, right? So it's unreduced, but it's y equals x minus 2 over 4 is the equivalent to that. Does that all that make sense? Okay. All right. For question number, 3, 4, and 5 really all kind of come from the same thing. This says we want to know what tangent of our cosine radical 3 over 2 is. So from this, what we're going to do is we're going to find cosine radical 3 over 2. Okay? Cosine is adjacent over hypotenuse, right? Okay? So what I know about this is that adjacent, so I should be getting radical 3 here, okay, 2 here, right? And because it's radical 3 and 2, I should be seeing what looks like a 30, 60, 90 triangle, or a special right triangle where my ratio is known, where this opposite side would be what? 1, right? And I know that this is 30 degrees, okay? So if I want to know what tangent is of this, right? Tangent is opposite over adjacent, which would be 1 over radical 3, correct? Which is going to be radical 3 over radical 3. And what I get is radical 3 over 3 as my answer. Okay?
So is tangent just multiplying?
I'm just multiplying there. So let me see if I can, I want to test this real quick to make sure I'm not telling you anything wrong before I put this in video format. So give me a second here. So what I want you to see is if you've got your book open, to go to page 223, because I want you to understand some of this stuff before we move on. Because you're seeing something in here that you haven't seen before, which is this phrase arc cosine, or ARC with a tangent. So you'll see like arc sine and and arc cosine and arcs, arc tangent, all those types of things. And so you do have some writing in your book that's helpful for this. If you notice on page 223, right underneath your picture there, you see something like cosine 60 degrees equals 1/2, cosine 300 degrees equals 1/2. And we can turn things around and ask for the angle whose cosine is 1/2 two different ways. You can say our cosine 1/2 equals, or cosine or inverse cosine 1/2 equals. Both of these statements refer to the inverse cosine, so you're still referring to the inverse of both of those things. The word arc cosine, which we abbreviate as ARC-COS, and the notations cosine to the negative first, both mean the same thing. That's the angle whose cosine is. Okay, that's what you want to understand. The angle whose cosine is. All right. Let's see. So I'm curious if we. Okay. Notice here how we got tangent 30 degrees is 0.57735022692, right? That's the same thing that we got whenever we found radical 3 over 3. Okay, it's the same decimal. So although you're thinking that I'm going to plug in inverse cosine in the calculator, really what we're looking for is tangent of 30 degrees. Okay? So if I can take the ratio of whatever the cosine is, it's the angle whose cosine is radical 3 over 2. And that's how we were able to find 30 degrees. Does that make sense? Okay? So then we're just taking tangent times that, or tangent of that degree. Okay? So it's what is the trig function of a different trig based upon a previous trig. And I know that's really wordy and really not maybe a great way to say that, but let's look at another one here and see if it still continues to make sense. Okay. All right. So we want to find our cosine of negative 1/2. We're not multiplying it by anything on the end. Okay. But what we have to understand is we're looking for the angle whose cosine is negative 1/2. Now, cosine refers to adjacent over hypotenuse. Now, we're always going to apply that negative to the numerator. So, adjacent-wise, am I going to be left or right of the y-axis? Left, right? Because it's negative 1. Okay, so we're at negative 1. So this is negative 1, and my hypotenuse is what? Our cosine. So what is cosine? Adjacent over. So what does the 2 represent? Hypotenuse. Okay, which means this here is radical 3, which means what is my reference angle here? 30. It's 60 because it's opposite of radical 3. The angle that's opposite of radical 3 in a 1-2 radical 3 is going to be 60 degrees. So it wants your answer in radians, which brings up a really good point. How do I convert between radians and degrees? Does anybody in here know? Okay, we have 60 degrees there. How do we convert 60 degrees into radians? This is an Algebra 2 thing. It's been too long. Okay. You want to be in degrees in your calculator. Okay. Let's see. So everything is based upon pi being 180 degrees. Okay, so we have a fraction times, essentially a fraction times 180. But ours is 60, right? So, let's see. Essentially what we want to do is we want to take 60 and divide it by 180. Okay, right, that would be 1/3, correct? Okay, let me double check on this. Because I've got 2 pi over 3, so I got something like 2/3. Because we're at 60 degrees, right? 60 over 180? Well, yeah, it should be 1/3. What am I doing wrong? Give me a second here. Because I've also... All right. So, I was a little off on this. All right. So what we want to do is we want to take our degrees times pi over 180. Well, that still, is that not the same thing? Okay. So it really should be the same thing. It should be 1 pi over 3. Oh, I think I understand why. I understand why it's 2 pi over 3. Because we're not really doing 60. Because if we're doing 60, all I would know about is that I was in the first quadrant, right? Okay? We want to know the true angle to get there, right? Which is 120 degrees, right? So that's 120 times pi over 180. So that should be 2 pi over 3. .09? No, you just want 120 divided by 180 because we're going to leave that pi in there. Did that come out to 0.6 repeating? 120 divided by 180. Should be 2/3. Okay. All right. Did we get this part of it so far? No, don't get it. All right, let me start. Do I need to start over at the beginning? Okay, well, let's do number 5. Hopefully we'll get it. Okay. All right, so Perla. We have our cosine 1/2. Cosine is what? So 1 represents the adjacent, which the adjacent's always going to be on the x-axis, okay? Over hypotenuse, which is my 2. So which quadrant does this put me in? First one, okay? So adjacent's 1, hypotenuse is 2, okay? And then what should go opposite? Radical 3, which means this degree here is what? So 60 degrees. Okay, so what we're going to do now is because we want this is what we were trying to solve for. Okay, we wanted to 60. So what we're going to do now is we want to convert to radians, so we're going to multiply that by pi over 180. Essentially what we're getting is 60 pi divided by 180 where we want to reduce that fraction. So 60 divided by 180, get a fraction there. 1/3. So we can write that as 1 pi over 3, or we can just write it as pi over 3. Okay, and get A for that. Does that make a little bit more sense? Now, like in the last one, if I ever wind up in a different quadrant, I want to go from the initial side to wherever that is and use that angle over 180. Okay, is that? Okay. All right. So I think that's about as much as we're getting into here because we are still dealing with the 4-quadrant stuff. And you are seeing some of the inverse. If you have questions as we begin to look at some of your homework numbers, I'll be here to help with that. And we've got about 14 minutes to work. So I want to make sure that you are working so I can help you with stuff that maybe you don't understand. Okay?